Thank you very much, John, and thank you to everyone actually for being here. It's now it's late, it's cold, it's winter, and we would be doing other things in other places if it wasn't for COVID. But eventually, here we are in a session. So I'm gonna start I'm just gonna start presenting myself, Jesus Escolar. I'm sharing now my screen. That should be okay for everybody to see the presentation now. Good, good. So I'm the CEO of Acceleris. We have also in the call Ignacio, who is actually our strategic account manager for EMEA. I come from a background on systems networking, security, and then a few years back, we started with understanding the DevOps environment and the DevOps infrastructures to add security into it, and actually to talk a lot and evangelize security through these into that ecosystem, where in the past we did it with normal development environments and all the separated or segregated solutions that we had at the time. So let's have a talk about it. I know that that's going to sound a little bit like in the beginning childish for some of you, because we're going to start a little bit from the beginning and then we're going to ramp up into some concepts, but it's going to be fun. We're going to go from baby talk to serious talk about security. So first thing we need to understand is, and actually integrate in our minds when we talk about security, is how the infrastructure has changed across the years, especially across the decades. So if we look at the landscape today, we are in between evolving from physical into virtual still. There's a lot of physical servers running in plenty of places. We're jumping then into cloud. There's a lot of cloud services delivering a lot of solutions for us. When you look into cloud, you can spend like days and days talking nonstop for 24 hours about what every cloud is doing, all the services they're providing. Then containers, and then serverless. For us, the goal of this talk is to focus in what can we do in the cloud for DevOps, what can we do with containers, and we don't talk about serverless. This will be another talk that we will do for DevOps Belfast in the next time. So everything has changed, and it has changed very fast. One of the concepts that people talk a lot, and especially there was some people actually giving me a hard time and giving to the people a lot of hard time about DevOps, which was the question of, is it DevOps security based? It has to be security infused. Does it actually needs to have security by default? The first thing you need to understand is, what is the meaning of DevOps in reality? So I may have some of you, for example, to kick in and comment after this slide what you think. But DevOps is an old concept. It's something that was always there. It was always in our hands. We were developing before. We were doing our job, producing product solutions, but it was never built as a word that gave us a framework and that gave us a process to follow to develop applications and solutions. As it says, our model, our actual model, was totally dysfunctional. It was ineffective. We developed a lot of solutions wrongly, with the right tools sometimes, with the wrong processes. We didn't have the proper cycles of development that allows us to be fast and effective. And we got to the points where it was absolutely non-organic, and it was not evolving at the pace that we needed. So we started putting development with operations to accelerate what we had at that time. We went from monolithic to multi-layered, multi-dimensional, so multiple possible outcomes across multiple possible tools and solutions that we could use. And absolutely, we added the multidisciplinary development environment. A lot of disciplines now join the development without having to interact with themselves. So before we had to be part of the dev environment, today we can be in DevOps doing stuff with developers, with with low-level programmers, with high-level orchestrators. We can have a lot of people working together and building solutions without having to be all of them devs or being outside of the business. It's a solution made for developers, by developers for developers. And this is where one of the problems starts when it comes to security. I'm not judging, sorry, I'm not judging wrongly the DevOps ecosystem. I'm just judging the fact that it was done by developers for developers. So it comes into the cycle that we all know, which is self-replicating and a continuous, never-ending situation that when you put it in place without thinking about security, you have to come with the idea of how am I going then to add into this cycle all the necessary security solutions to make it effective. If we look into all the possibles, and those, this is only, it's impossible to put everything there because the real page is amazing. It's full of solutions, but you got so many solutions to put in place, and these are only part of it. So imagine when you need to actually look into how you do you plan into building a continuous, scalable, and stable security in this process. It can be overwhelming, and at some point you can actually even reach the point where you're not going to be able even to produce what you expect as a result from the security standpoint. This is the slide, okay, that is dated on, that one is dated on the 6th of January, that puts all the possible solutions that you can have in a DevOps environment, depending on which blocks, in security, in container registry, in automation and configuration, in cloud native storage, and so on. Look at the number of logos. That means one product or multiple products. And if you jump into the serverless, then we are already working with a lot of solutions. So thinking about something that was supposed to be delivered so fast and so quick, it is already being overwhelmed. One other thing that happens with DevOps is that we want to build secure. So we want to build code that is actually workable, secure by default, and that you can be compliant with the standards and requirements of your organization, and eventually with the compliance and requirements that you are going to be tied to. You need to ship fast, so you need to build and you need to deliver very fast. So you need the minimum amount of friction when it comes to security. You don't want to be blocking the process of development. It needs to be running anywhere. So the security needs to be optimized to be under any platform and any solution. So either instead of fighting the existing environment, you need to adapt and you need to actually jump into that bandwagon. But the problem is different, because what happens is that you get the security into place too late when actually the problems and the issues have already happened. And you don't want to be, okay, the next person in line to replace the person who did the job before you. Conditions that we are facing today, and those are conditions, now we're jumping into more the conditions about threat intelligence and everything that's related with the dynamics of the business, and how do we actually look into security, on why security is important and why security is going to be important for DevOps. There are new security conditions coming because of the dynamics of the changes, the fast-paced change on our infrastructure, on apps, and the sophistication of the threats. The threats are becoming and evolving and becoming way more complex, which they jump into the pain that is inflicting to the customers. You need a lot of protection and auditing and maintaining this compliance up to date. You have a problem about where do you actually plan to put your solutions? So which clouds are you choosing? How do you expect those clouds to work and interact? So you need to measure whether the solutions that you're putting and the security measures that you're putting are not impacting your operations. And then you move into the fact that, do I have the resources that understand what I'm actually doing? Or do I have the enough technical understanding of what is being set into place in order for me to run my business. And when I say running my business, I mean running my pipelines, running my DevOps framework, and delivering my product. Because remember that at the very end, the show must go on. So you still need to keep on producing, no matter what technology you use. At the end, all of this is to produce a product, and that product is to be sold. Whatever is an app, whatever the outcome is, but the show must go on, frictionless. The security paradigm that we have today with the model coding, which means basically how we code today, is that we build containerized content or microservices, and we deliver them into our environments. In that case, we can deliver them, for example, in our cloud environments. So the points I expressed that are very important. The legacy security innovators are the top 5, possibly the top 10 security companies that are actually bringing solutions into the table for security for normal environments. They're taking their adoption of changing their innovation on security for the DevOps environment very slowly. We see very small, very little amount of products that are able to support and sustain continuous security a continuous security delivery on your environment. Coding goes very fast, so too much code, too many errors, prone to a lot of problems and mistakes. The techniques are new, and they keep on coming and coming and coming. And the controls that we had in the past, they cannot no longer be used now, because in the past we used to control the code, prepare it, check it, and then deliver. But we were slow. We were taking our time to deliver. Here, we have a lot of cost and complexity, and obviously we're breaking a lot of processes, especially with the fast-paced environment of a DevOps environment with a pipeline. The outcome of fast-coded apps gives a lot of supporting solutions. You've seen the slides. We have a lot of solutions to support the different needs of each of your your companies and all of the individuals that are building any kind of product. So we need to focus on how do we compartmentalize them into groups and to decide at what point in the which location do we want to put security. We cannot be just plugging into every single solution that the vendors are bringing to help you develop. The amount of code that is insecure is massive. There's a lot of code insecure. You can check it in the internet, doing any search about, I want to see the vulnerabilities of apps. Can I see the latest vulnerabilities found in applications? You will find that some of the vulnerabilities are just wrong decisions or bad decisions. They're not about doing something wrong and putting bad code. It's just about doing things so fast that you actually deliver solutions that are not checked and unprotected. For the containerized applications, we are already in a controlled state, so we can think about how controlled it's going to be and how efficient it's going to be, because we have been evolving over the years and putting the right security controls and solutions in place. The adoption is going very fast, and the traditional security vendors, they are rebuilding their solutions to actually deliver and include from their legacy. I wouldn't call them legacy, that's the wrong word. It's not legacy. They are solid security solutions, very stable, very strong, and they are now being rebuilt slowly to adapt to the DevOps environment, so they can fit the model that we're going to talk about. The landscape today, in terms of security, is a lot of customer pain, because in the DevOps side, we need to increase security and compliance, and those requirements are causing a lot of unexpected work and delays. So they're wasting a lot of time in the customer side, reworking processes to meet the security requirements. The security is also slowing down the developers and the DevOps teams and the DevOps process, because you miss the deadlines by following all the process and putting it into place. You miss the time to market, the targets, because it's too hard to implement, and sometimes is not even automated. Then you get to the problem of incompatibility. So you got tools that are not even listed as validated tools or tested tools, or they are not even optimized for the cloud model that you're using. So then you need to create new interfacing solutions to add the security into those environments. And that is absolutely sometimes even impossible, where you have to say, okay, if you want to be secure, you're going to have to change what you have at the moment and create a new type of pipeline with a different set of solutions. So it's a lot of pain for the customer. Let's talk about we talked about the problems of the customers. We've seen that there is a lot of pain coming into the customer's hands because we're using those the approach of securing the environment. But let's just start putting some words into place, because also I love to have this fight about what is the right word. I know that most of you are talking about DevSecOps, but I don't really like it. It is what we have at the moment, but it's not really in reality what we actually need to have. And there is an arguing point about, do we even have to include the word sec? Well, we do, because otherwise it's just development with operations. It's just a mix of both of them. I don't see how implicit and intrinsic the security can be if I don't express it clearly. So DevOps sec will be when I'm taking the security procedures, methodologies, and engagements at the very end, when everything has been done, when I have finished my development, my deployment, and my operations. That approach is very dangerous, because what you do is you put applications in the wild, and then you check them, and then you see, wow, we got vulnerabilities. Whoa, we forgot to check into this. That's probably coming from these lines of code. Now we have to go back, but the application is still in the wild. It's running already. It's there. It's published. So you need to go back and think, okay, what are we going to do? Well, we cannot do anything. We cannot stop what we have done. We're going to fix it in the next release. And this is very, very, very close to the model that we had in the past. You deliver something, and then when somebody comes back and says there is a bug, there's plenty of bugs about security here, well, we're going to patch it, or we're going to release a patch for it later down the road. DevSecOps is where we are at the moment. It's actually where we sit. That is actually where the scenario where people are working. So what we do is the devs are leading the pack, okay, and they're giving the highest importance. But then it gives you the ability, okay, to, in the middle, put the security before you release. So you leave the process going on, you put security, and then you deliver. So security is not prioritized, but it's there, and it's good enough to address a large set of needs that are at the moment required for the DevOps environment. And the best is if we do SecDevops, which means that we include security and the security discussions, best practices, processes, compliance, frameworks, engagements in the beginning. So before you create your environment, before you create your teams, before you even start working with the people and developing, you put the people, all of them, aware about security. You engage them, you tell everybody the roles and responsibilities, and all of the methods and techniques that they're going to have to use in order to start developing, either developing or on the operations side. So it doesn't matter. They're going to work, both of them are going to work on that way, which means that the first brick that you're gonna lay is the brick of security adapted for DevOps. And everybody's going to play the game. And everybody's going to play a transparency game, stating very clearly, we're going to adopt the methods and techniques, and we're going to follow them. It's very difficult to get it in place. Some of the attacks that you can find, for example, in CI/CDs, okay, And some of the cases that you're going to face when you are actually in an environment where you totally don't have the proper control, or you just land into the place to perform development, and then you're going to tell me, yes, Jesus, but we know, for example, that we apply the best practices, and I'm like, that's very nice, but we apply the best practices, the security guide on best practices, and I'm like, yeah, that's very nice, but you should do that anyways. You shouldn't even tell me that. You don't have to tell me that. You have to do it. I expect you to do that. I expect you to do the whole set of best practices. And if you can't, you need to tell me the exception on why you cannot. But you don't have to come proud and say, oh, wow, I'm using the best the best practices security guide, and I should be covered. No, that's the minimum. Then it comes what we're going to put there as a solution, the discussions we're going to have, or what is going to help to level up the game. Examples that could happen in a containerized environment, for example, is fork bombs, where the processes can just explode in hundreds, just growing and consuming resources. Or for example, in an environment with multiple containers, there will be a unwanted communication across them, or the unauthorized pivot traffic. How are you going to do lateral movement? Okay, in an APT, which is what we call an advanced persistent threat, the phase number 4 is lateral movement. When you actually have already a strong foothold in an actual environment, and what you do is you start escalating and moving across all the different resources to find better, more critical, and more sensitive resources to start gathering data. Rogue images, orphan images that you can have that are lost, or rogue that are, for example, or forgotten, rogue that are images that shouldn't be there. So rogue processes or libraries that should not be there, people hijacking, for example, libraries and making people develop with hijacked libraries that then they put it into the applications. Volumes that stay persistent. So once you run your applications and you no longer need them, the volumes where the data are and the data is located, they keep on being there. They stay persistent. Cryptojacking container host, that's a very nice one, because that's what we're going to talk about in the example. You can have, for example, containers that are running in an environment, and what they're doing is that they're actually just crypto mining on the environment. Persistent attacks, so establishing malware that is going to start communicating to command and control servers, so zombifying your devs environment. So every time you spin your resources and your applications, they're going to be just being communicating back to those servers, and at that stage, giving these people control. Fileless attacks, for example, the POC, the proof of concept, graphically, I'm going to just show it later, just in the next slide. So the next slide is an example of this is one of the vendors, but you know, every vendor, all the McAfee, Sysdig, Tremicro, all of them, they create slides. And this is one slide that I love a lot because it has all the process in the different stages, showing you, for example, what happens when there is an attack, okay, in an Ubuntu container that actually somebody just put it there to spin it to run an application. So what happens is that somebody connects to an open API port in a Docker daemon, okay? And then, boom, it launches the container, okay? Then the container is going to automatically download a shell script. Boom, the shell script is coming. You run it, okay? And then it becomes persistent via cron tab, so it stays persistently there. It runs continuously, even if you remove it. It downloads a piece of malware from this address, okay? So it gets this Kinsing malware, okay? Which then it's going to start downloading a lateral movement script to actually check what are the available additional the containers resources that I can keep on hacking. At the same time, it will then run communications to the command and control. So you're already zombified. Okay, your resource is zombie. You are being controlled by a remote malicious server. You have another shell script that's going to try to detect all possible credentials and keys from other possible resources. And also, just as a gift, I'm going to run a crypto miner to just start mining on the behalf of your resources. And this is a real example, happened many times. And we can talk about plenty of those. There is some questions going around here. If somebody can manage the
I think we're okay for now, Jesus.
okay. So so that is the one of the examples. And one of the things that we need to do that is very important that people are not very aware about is that we need, when it comes to security, to map what we do with security with the Mitre attack standard framework. Okay, so you get the link there. You can have a look into it. It's a very interesting standard that provides you with all of these steps: initial access, execution, persistent, event evasion, credential access, discovery, lateral movement, command and control, and impact. And when you see all of these verticals, what you do then is you find what is the box or boxes that you are covering in each of the different attacks. This is a way to measure, when you're monitoring for security issues, your environment, how do you actually map every detection that you have with the Mitre standard. So you will have techniques and tactics that you're going to actually see inside the standard. And the tools usually should map what's happening with those techniques. There is also a special for all the DevOps or most of the DevOps environment. There is a special Mitre set of PDFs that explains what you should see in security. I will give that to John later, and John will be able to disseminate that to you. What is a standard to follow? So how do we fix that issue? How do we actually go from having those problems to solve them? We need security frameworks that have to be frictionless. We cannot be fighting the actual teams and the DevOps teams and the DevOps environment. We need to be frictionless. We need to integrate into the code pipelines without disrupting the people. We cannot bring more problems. We need to look into the first detections for malicious content. We need to continuously monitor for potential threats. We need to see historical data and activities and build a behavioral baseline, and obviously provide some forensic content that on forensic tools that we are going to be able to use to gather forensic data in case of an incident. We need really to be nice and cool and really invisible. We cannot be present in every action of the developers and knowing them. We have to be really, I wouldn't say invisible, but not an annoying part of the equation. And it has to be fast because people are not going to wait a year for you to find the right time to implement it. The teams in the DevOps environment, they have to think about how they are going to reduce the evaluate first and start making the surface, the attack surface, smaller. So examples are hardening the pipeline, for example, locking down the systems that host repositories, the config managers, the build servers. The monitoring the pipeline, you must have a total visibility across the services. You need to be able to have arbitrary audits, and therefore actually anything that you're using should be audited regularly, okay, and making sure that they are not prone to external attacks. You need to use trusted secret managers for your credentials. That's mandatory. Airbag, you need to have role-based access control of what person can actually access what into the tool chain, okay? No anonymous, no shared access resources. You must have immutable logs, which means that when the logs are there, they cannot be changed to avoid tampering. This is critical for compliance. especially for compliance. You need to include if you're running on containers, container security, and you need to add code analysis tools to analyze the code, because everything can start from your keyboard. So part of the solutions into the pipeline, now we're going to see part of the solutions is to actually add in the pre-committing SAST, okay, in your dev environment. Then you can actually, when you're committing, do an incremental SAST, okay, in the build, SCA and SAST. We're going to talk about that later. When you're doing the test before the deployment, you can do actually EAST and DAST. You can actually do hardening. You can do fuzz testing, just, tests that are just trying to figure out whether I can actually gather potential vulnerabilities or not. And at the very end, you should do, when it is in production and you already deliver your solution, you need to be doing the monitoring, pen testing, and you must be doing red teaming, basically attacking what you have created to figure out if it's vulnerable or not, and if you find vulnerabilities, to come back. So very interesting slide, this one, that puts together three elements: SAST, SCA, okay, and SAST and DAST, okay? So SAST will be your static application security testing, and DAST will be your dynamic, okay? And the SCA will be a static code analysis. So they are totally different, all of them. And the problem we have is, and the question that I will leave for you to discuss together at the end on Q&A, is what would you put all of them? Would you do everything? Will you choose your battles? I'll leave that question open for the end. Would you do it? Would you attack all your problems with all the tools that you have? Or would you just say, I'm going to focus in the middle, in my builds before deploying? I'm going to forget the code. I cannot handle the code. I will do it just in the commit. Or I don't even think about going at the very end and doing everything that's about testing my applications at the very end for vulnerabilities. So for example, we've got some things here. It says, in SAST, we detect vulnerabilities in proprietary code, while in static code analysis, okay, it detects vulnerabilities in open source. There is a lot of differences between them. I don't think that they are totally exclusive. I think that we should use whatever fits best in the code analysis, in the application analysis, what fit best my development model, and then try to actually define what is going to be my risk appetite based on my capabilities to monitor and analyze every single step of my pipeline. In SAST versus DAST, for example, the differences: in SAST, we do white box. So what's the difference between a white box and a black box? Well, the white box, I'm telling everybody what it is. I'm telling, hey, here it goes. I got access to everything and I'm testing absolutely everything with explanation. Why in the black box, you have no knowledge. So you need to actually, you need to discover by yourself what you're doing and what you're facing. In SAST, I need the source code. In DAST, I go to the application itself. So it's totally two different approaches. Do I do it? I can do both of them. In SAST, it's less expensive to fix the vulnerabilities because, well, I find them. I just need to tell to the people to do the things right, what they've done wrong. While in DAST, because it's dynamic, the vulnerabilities are at the end. So I need to actually go either back or just decide that, well, I don't even know in reality. I don't know in reality how do I fix it without building like a hotfix, for example, or just going very, very, very fast into I'm just getting lack of water without actually going back to the code. So I like to combine both of them. So let's talk about what happens when I am in my pipeline. And then I put, I'm very sorry about this. I use standard names I know not everybody uses all of this, but if I had to put every single product to make everybody happy, I would need a slide deck of the size of Manhattan. So I cannot use that. I have to use whatever is the size to the name. So you know what each of the things represent in the question. So I got my developers, they're actually committing. They just commit. Then I get to building, and then I get to pushing, okay, in my registries. And then I get to actually running my application. And I am Jesus in the very end, consuming the application where you can see my little lockers there, okay? So if I go back, my first step where I can actually in a pipeline start producing security results is by scanning the builds, integrating myself, for example, with Jenkins. Then another step I can do is scan the registries where I put them. Then I can create an admission control who, under which conditions, can actually end up being a running application. I will define my conditions, and I will test and say, based on these conditions, this application is going to actually run. If not, it has to be rejected. And until those elements are object elements are fixed, the application is not going to be admitted. Then I can go and check in the runtime, is there actually malware inside and vulnerabilities? So I do basically a vulnerability scanning and a malware analysis to find if there is any kind of malware there. Then I go and I start protecting my platform, which means I'm going on a lower level, protecting, for example, Kubernetes, for example, or Docker, and say I'm going to protect the bases where I'm actually building my solution, running them. Then I will go and do the host protection. I said airbag, not ABAC. But that's a very good one. That's a very good one to talk later. And I will just protect my hosts, okay? And then you have the intrinsic protection for the containers and eventually for the serverless, which means that within the container, I'm going to be running my solutions, my response to the problems. So let's look into the same, that comes to the same example. I'm jumping here, okay, and what I'm doing is continuously scanning, for example, the images for the vulnerabilities and malware. So I commit, they get built, they get scanned, and when they get scanned, either they pass and they go and I do, as I said, my admission control, or I get an alert and boom, somebody gets alerted. This is not going to be deployed. I'm sorry, it's not passing. Go back and fix all of these issues. And the people can actually go and check all the issues that they have been found before they deploy the solution. So the build pipeline is that the risks that we have there are based actually in the fact that, for example, there could be actors, and there have been examples that they can actually inject malware or vulnerable libraries into the pipeline. And I'm going to use them without being even aware if I don't have security solutions there to check that, because I don't have a threat analysis solution in place. Or, for example, there will be vulnerable code that I wasn't aware about that somebody put there that I reused without knowing. This is a very classical one, the reusing and reusing and reusing. I have a very interesting example that was based, and don't remember, but I saw a nice Twitter about Disney being one of the first organizations reusing animations. So if you see some animations from many years back compared to some animations today, you will see that they reuse the same movement. So it's actually a very a cyclical process. So if they reuse that, imagine what happens with code. It gets reused like crazy. And the misuse of dependencies. People build stuff based on elements that they need, that they don't even know if they're vulnerable or not. And if the process of admitting those packages and libraries is done without a security check, you end up in a situation where you don't have the control of what is secure and insecure. The idea to mitigate them will come with the fact of doing the solutions we talked about, vulnerability assessments, vulnerability shielding, blocking the vulnerabilities, because there is two ways to approach the problem. One of them is to detect the vulnerabilities. The second one is to shield your system for the known vulnerabilities without having to stop the show. The show must go on. You block them, and what you do is you think about how you're gonna just fix that and come back. Malware detection could be done by machine learning or signature-based. Continuous scanning, keeping on actually maintaining the scan of every build and commit that people do. Scanning back, that's called retro feedback. So the thing about the retro feedback is that people forget that you may join an organization to provide security 2-3 years down the road, where people already have devices and they had they already established the way of working, and you need to go historically back and figure out, was everything right before I joined? So you need to have an ability and a solution to do that historical analysis. You need to maintain your immutability. Otherwise, the problem is that the code and the libraries that you use, if they're not immutable, if they're not controlled, they're going to be potentially modified, and therefore it could be you could land into a case where you could be using infected code. And it has to be automated. You have to fully automate the process, transparent. What is coming now, and what is this is my conclusion for the talk, is the fact that it is evolving and changing every time. Or environmental pipelines, they're changing. You can infect absolutely anything: hosts, code, images, applications, and the pipeline can be compromised on all the different stages that we saw. In all the Black Hat conferences, there's a lot of demonstrations about code and Docker images and all of the DevOps environment being compromised. And now there's more and more players in the market demonstrating that. The goal is to use a next generation solution that provides an anti-malware, non-signature based analysis, behavioral analysis and baselining. So building the persona of your environment, building the image and the standard view of your environment to allow to create that baseline, continuously monitoring, adding machine learning and artificial intelligence into the solutions to be able to forecast, see the existing and say if it's good or bad, and also forecast what could be bad from what you're doing, vulnerabilities analysis and shielding, and sandboxing to detonate anything that you have put in your pipeline as libraries or executables that could actually scripting, anything that you can execute, detonate them, visualize them, and see their behavior in an environment that is controlled and that actually reflects in a report, in an outcome, if it was good or bad. And DevOps, as we see here, I decided to put it in the right place with a sec in the middle instead of putting it in the beginning, because I would have created a lot of what do we call it, scars. It's based on the addition, on the sum of the actual devs plus the ops minus all of the integrated security. This is how you actually, little by little, the security is going to reduce the attack surface and the risks that are in the DevOps environment. Thank you very much.